A very good day I bid to our course coordinator. So we are from group 6. We'll be conducting task F, batch reactor for biodiesel process for activation energy. According to Siva Prakasam and Saravanan 2007, transesterification defined the process in which fat or oil reacts with an alcohol to produce esters and glycerol with the help of a catalyst. So in our open-ended, we use sodium hydroxide as a catalyst to increase the reaction rate and yield. This is because the reaction is reversible. Excess alcohol is used to shift the equilibrium to the product side. As shown below is the chemical reaction of transesterification process, where triglyceride or the waste cooking oil will react with an alcohol with the assist of catalyst will produce biodiesel or alkyl ester and the byproduct glycerol. These are the stepwise reactions of transesterification of biodiesel process. So the first one is triglyceride Tg will react with an alcohol will produce diglyceride and also alkyl ester. So the second step is Dg, diglyceride, react with an alcohol will produce monoglyceride and alkyl ester. So the final step is monoglyceride, Mg, will react with an alcohol will produce glycerol and also alkyl ester. According to Krishnan and Das 2012, in the first step, final concentration of Tg is converted to final concentration of Dg and metal esters. In the second step, Dg is converted to final concentration of Mg and metal esters. In the final step, Mg is converted to glycerol and metal ester. In this case, Krishnan and Das were using methanol as the alcohol. For this open-ended, Group 6 is required to find activation energy of biodiesel process. Activation energy is the energy required to proceed from the reactant state to the transition state, according to Bogaku et al. 2011. The equation of activation energy can be presented as shown below. Activation energy equal to negative RT ln K, where K star equal to K small k over A. Activation energy with the unit of joule per mole. R is the ideal gas constant with the value of 8.314 joule per mole K. T is the temperature in Kelvin. Small letter k is the reaction rate constant, and A is the pre-exponential factor.
For the experiment objective will be to produce biodiesel from waste cooking oil, to determine the activation energy of the transesterification reaction, and lastly to determine the relationship between concentration of glyceride and temperature. Next will be the experiments variable. For the manipulated variable is the temperature of reaction, the responding variable is the concentration of glyceride, and lastly constant variable will be molar ratio of methanol to oil and the mass of sodium hydroxide used.
So next is experiment hypothesis, which is I'm going to explain about the expected result from this experiment. Based on the variable mentioned previously, the effect of temperature on metal ester formation of waste cooking oil is carried out at various temperatures, such as 50, 55, 60, and 65 degrees Celsius. Therefore, the relationship between the temperature and the concentration of glyceride, Tg, Dg, and Mg, as well as metal ester, are shown in the figure on the left side respectively. It is shown that the concentration of glyceride is decreasing while concentration of metal ester and glycerol is increased higher as the temperature increases. This is also related to the conversion of triglyceride to metal ester, which is shown in the figure 1. At 60 degrees Celsius, the conversion is at 94% conversion, which is 60 degrees Celsius is the optimum temperature for this experiment. So after that, the known concentration of glyceride and metal ester can be used to determine the activation energy. So the table shown on the right side is the activation energy for meta-analysis of Tg, Dg, and Mg during the transesterification of waste cooking oil. So the also activation energy of the 3-triglyceride reaction had only less energy required, exhibiting the conversion of triglyceride. So this is the expected result, and this expected result is taken from our kinetic study of biodiesel in less gluten oil, which is studied by Krishnan and Dash in 2012.
Hi, my name is Claudia Carissa and I'll be presenting on the methodology part for our open-ended lab. So for the materials in our laboratory, we'll be using waste cooking oil, 100% ethanol anhydrous, and sodium hydroxide. And the apparatus will be using Erlenmeyer flask with stopper, separatory funnel, measuring cylinder, hot stirring plate, magnetic stirrer, thermometer, aluminum foil, and weighing scale. Next is the draft methodology for the laboratory. So there are 15 steps in total. As explained earlier, the manipulated variable in this project is the temperature. Therefore, steps 1 until 13 will be repeated with different temperature, ranging from 50 degrees Celsius, 55 degrees Celsius, 60 degrees Celsius, and 65 degrees Celsius. So the temperature changes are set in the steps 7, 8, and 9. Lastly, in order to analyze or investigate the effect of the temperature on the quality of the biodiesel, the samples collected will be analyzed using UV VIST, and the data collected will be recorded in a data table.
For safety and precautions of methanol, first, the container is stored in a cool location and kept tightly sealed. Second, the methanol is used in a chemical fume hood. Third, the storage of methanol near extreme heat, ignition sources, or open flame is avoided. Fourth, the methanol is protected from freezing and physical damage. And lastly, the chemical waste is transferred and stored in a closed and leak-proof container, secondary containment, and in a designated location. As for sodium hydroxide, which may be in a pellet form or liquid form, so first, the safety precaution is the sodium must be kept in a tightly closed container. Second, the container is stored in a cool, dry, and ventilated area away from sources of heat, moisture, and incompatibilities. Third, the sodium hydroxide is kept away from acids, metals, flammable liquids, and organohalogens. Fourth, water is not allowed to get into the container due to violent exothermic reaction. And lastly, which is similar to the methanol, the chemical waste is transferred and stored in a closed and leak-proof container. As for personal protection, a pair of gloves that is chemical resistant, safety glasses with side shields, and lab coat are worn when handling the methanol and sodium hydroxide. Second, the contaminated gloves are disposed appropriately after use. And lastly, hands are washed before breaks and immediately after handling the methanol and sodium hydroxide.